Let me create the binary tree of value 1, another having two nodes, two child node 2 and 3. So one path from root to its leaf is 1 and 2 and 1 and 3. So we can say there is one path from 1 and 2 and another from 1 and 3. So we can do a traversal of reaching all the leaf nodes and we can remember the path. So the basic formulation would be, let's say 1, and it is going to go to 2, and similarly another path from 1 to 3. Now one question might be arising, how you are making the values or transformation. So there are two ways of doing it. So one, I can form it in a string format or I can form it in a number format. Now let's say if I'm doing a pre-order traversal, right, the first value I can create, let me create a function def dfs, and I'm going to pass in the root, and another could be, let's say, path. Now in case if not root, in that case nothing is forming, so we are going to return 0. Now one more thing to understand, what will be the value of the path? So I can say path equal to path multiplied by 10 plus root dot val. Reason being, let's say first our current path value is 1. Now we are getting another path value. So how are we going to add it? So 1 into 10 plus 2. So value would become 12. So that is the basic idea formulation. Now once we are going to the leaf node, right, we are going to add that to a stack. So let's say I can create a stack out here and I'm going to give it an empty. So if not root dot left and not root dot right, so basically we are at the leaf node. So in that case we can say stack dot append our, let's say, path out here, or we can just form our formulation. If you don't want to do it, we can basically say return dfs of root dot left comma our current path plus dfs of root dot right dot our current path. So if I don't want to add in and stack and then calculate it, we can also do it in a recursive way, which would be much more simpler. And in that case, right, we can just basically call this dfs function with our passing our root, and initial value of our path is going to be 0, and you're going to get a result. So here, right, how many paths are you going to form? So first would be 12 and we're going to get 13. So our answer is going to be 25. So that's a pretty straightforward and simple solution. Now let us jump to the Python implementation. Hi, the first thing we're going to do, we're going to create our function, let's say dfs, and pass in the value of root and our cur sum. Now the first thing of dfs is that you have to check, if not root, then return 0 in our case because we are just calculating with numbers. Then the value would be cur sum plus or equal to cur sum multiplied by 10 plus our current root dot val. Now we are going to check if it's a leaf node or not. So if not, root dot left and not root dot right. So we can basically say it's a leaf node because it does not have any left or right child. So in that case, we are going to return the current sum, cur sum and then we are going to call our function recursively. So dfs root dot left comma cur sum, and you're also doing to do or return the sum of all the paths. So plus dfs of root dot right and cur sum, and at last we are going to call dfs of root, and the initial value of the path or the cur sum is going to be 0, and we're going to return it up. So that's the basic solution. Let me run it up. As you could see, the public test cases passed successfully. Let me submit the code, and the time complexity of it is going to be big O of n, because we are traversing all the nodes one time. That's all for this video. See you in the next one.